So we're going to take a look at the magic square question that we had in the practical programming test. To start with, we'll just assume that we maybe have a 4x4 magic square. So we'd have, let's say, A, B, C, D, E, F, G, H, I, J, K, L. Okay, so we've got this square. These numbers are all variable, so it doesn't actually matter what they are. But we need to check the following. So we need to add up all of our rows and make sure that all of the rows equate to a specific number. We also need to add up all of the columns, make sure that those add up to a specific number. And then finally, the last requirement is that we actually have to check the diagonals. So we have to check the whole diagonal here and the whole diagonal here. So let's take a look at what we would need to do in each case, but we'll do it as a flow diagram. So before we draw the flow diagram, we must actually look at the requirements of the test. And one of them was that we can have a maximum of a 10 by 10 magic square. So that's there and here. Okay, so that means that we could have a maximum of 100 numbers, and it can only be smaller than that, or 100, right? So let's look at what that would look like. Because it's a limitation, we can actually use it to our advantage. If we had a 3 by 3, right, all we would do is we'd create this array that's 10 by 10, and we would just use this little bit here. And let's say we had a 5 by 5, we would just use this little bit here. So we would send the whole array to every single function, but we wouldn't actually look at any of these pieces here. We would only look at the n by n part that we need. Okay, so now let's look at what that looks like in a flow diagram. Okay, so what we're going to do is we're going to start by creating a function that just sums up a single row in the 2D array. Okay, throughout this video, I'm going to call rows I and columns j. So what I want to do is create a function that just sums up one row. I choose the row. I can say row 0, row 1, row 2, however many, and it will give me the sum of that specific row. So let's start up the flow diagram for that. Okay. So we're going to have our start block like usual. Okay, in this function, we're going to start off with the input that we send to the function. So we're going to send an array, and we know the size of this array. It's going to be 10 by 10, because that was the maximum size it could be. We're also going to send n. N can be anything less than 10, obviously, but that's the size of the actual magic square. And finally, we're going to send the row, which we'll call I. Okay, cool. So we get all of that input, and the next thing that we need to do is start initializing our variables. So the first thing we want to initialize is the sum variable, and we'll set that to 0. And we're going to have a for loop, which we use to go through every column in a specific row. And since it's columns, I use j for that, so I'm going to say j equals 0. Okay, so I've initialized all of my variables. I'm now going to ask the question, is j equal or less than n? Is j less than n? Because we're doing a for loop, and we're going to run through all of the columns possible, right? And so let's start with the yes, if it is. So if j is less than that, then our sum variable is equal to itself plus the array at the row I and the column j. Okay? The next thing that we have to do is, because we're running a for loop here, we're going to then take that and increase j. Cool. And finally, we'll return back to our j block. So let's come in here. And then if j is not less than n, that means that we're at the end of this loop. And if that's the case, then we return j. No, sorry, return the sum. and we end. Okay, so this is the flow diagram that sums up just one specific row in the 2D array. So this is for yes, and this is for no. Okay, cool. So we've got the flow diagram for that. The next thing that we need to do is create the function that sums up each row and checks that they're all the same. Okay, so in the previous slide, we created this function, and let's give it a name. So let's call it sum single row. And what we would send it is the array n and also the row I. Okay, so that's the original function that sums just one row in the whole flow diagram. Let's now create the flow diagram that checks every single row and makes sure that they all are the same. So again, we're going to have our start block. Cool. And now the input that we're going to need for this function is the array, which is a 10 by 10, and the value of n, which is how large the magic square is. Okay, cool. So now the question comes, how do we compare every single row and make sure that they're all equal? Because if they're not equal, we need to return -1 or let the user know that they're not equal. And if they are, we would obviously return the count. So let's start with creating a count variable. But we know that this magic square must at least be one number, right? It has to be a 1 by 1 at least, but it can't be greater than a 10 by 10. So let's create a value called count. And we're going to set count equal to, so I'm going to put that on the next line here, equal to sum single row. I'm going to send the array. I'm going to send n, and I'm also going to send 0, which means row 0. So basically what I'm saying is that my count variable must be equal to the sum of the first row. Okay. So that's number one. We've got an idea of what the rows should add up to. Now let's create a variable called I, because now we're going to run through every single row. So we're going to set I equal to 0, right? And now we're going to ask, is I less than n? Because it's a for loop. Alright, so let's start with if it is, yes. Okay, so now what we want to do is we want to create a temporary variable, and we're going to say our temporary variable is equal to the sum of a single row, and it's going to be our array n, and we're going to send I. So I is constantly changing. In fact, based on this, we actually don't need I to start at 0 because we've already counted the first row. So let's, if I could figure out, I'm just going to cross this out, and I'm going to say I must be equal to 1. Okay, cool. So we've now created a temp variable, temp, and it sums up the next row. And now we ask, does temp equal the original count variable that we had? Okay, so now we're asking, so we're now on the first row. We've already got the count for the 0th row, the very first row. We're now on the second row, sorry. We've already got the count for the very first row, and now we're asking, does the count for the second row equal the same count for the first row? If they aren't equal, we already know that this isn't a magic square, right? Because the rows don't match. So if it's a no, we can already just kick this out. So if it's a no, we can return -1. Okay, and I'll get back to that later. If it's a yes, right, that means that this count of this row is the same as the count of the first row. If it's a yes, Then all we need to do is increase I. We need to move to the next row and check again. So all we're doing is we're running through every single row and making sure that every row is the same. Right, what happens when we get to a point when I is actually is greater than n, right, or equal to n? When that's the case, it means that we've gone through every single row and all of them have added up to the same value. That means that we can return the count, right, because that is what the sum of each row is. Okay, now finally what we need to do is just put our endpoints here. So let's create an end variable, end, and to end off this function we either return -1 or we return count, and we've ended. Okay, cool. So this is now the flow diagram for counting, checking every single row and making sure that each row is the same. So now the question is, from here, can you do the column question? So it would be a very, very similar concept for columns. We need to check that we can first sum up one column, and then from summing up one column, we can sum up each one until we get to the end and make sure that they are all equal. Okay, now let's take a look at diagonals. Now, with the diagonal, what would happen is that we would need to check these four numbers, but it doesn't have to be 4. Obviously, n can change, and these numbers over here. So for the first one, this is 0.00. This becomes row 1, column 1, row 2, column 2, and row 3, column 3. And here we've got row 0, column 3, row 1, column 2, row 2, column 1, and row 3, column 0. Okay, so we've got an idea of how the columns work, the pattern that we're trying to check. And so let's start off our function. Cool. So we're going to have our start. And from the user, we're going to receive an array, which is 10 by 10. And we're going to receive n, which is the size of the magic square. All right, cool. So we've got the input from the user, and now what we need to do is create two variables. I'm just going to call it D1, which is the first diagonal, and I'm going to make D2, which is the second diagonal. Okay, so I've created these two variables. Now I need to create a for loop to count through these diagonals. Now there's a pattern there. 0, 0, 0, 1, 1, 2, 2, 3, 3. That could be one counter. And when we go 0, 3, 1, 2, and then 2, 1, and that's basically that one is counting up from 0 to 3, and the other one's counting down from 3 to 0. That can also be one counter. So let's start by creating a counter k. Okay, and now we ask the question, is k less than n? Okay. If it is, whoopsie. Okay. What we need to do is we need to sum up the first diagonal is going to go from top left to bottom right. So D1 is equal to itself plus our array at k and k. Cool. That was quite a simple one. The next one is for D2, which is slightly more complicated, and that's D2 is equal to, okay, it would be itself plus our array. So the row starts at 0, but the column starts at n minus 1 minus k. So basically when k is 0, if n was 4, this would be 4 minus 1 is 3, minus 0 is still 3. And as soon as k starts increasing, we have that the row increases linearly, so 0, 1, 2, 3, and the column decreases linearly, so it goes 3, 2, 1, 0. Cool, so we've got the two diagonals counting up, right? And then what we need to do is just finish up the for loop. So we've got k++, and that then carries through. And if that's not the case, if k is no longer less than n, then we need to now check to see if okay, sorry, let's not use if notation. So does d1 equal d2? Okay, so we now need to ask, are the diagonals equal? Because for a magic square, they have to be. So there are two ways, there are two possibilities here. Number one, yes. All we have to do is return one of them. We can return d1 or d2 because they are the same number. If it's a no, it means that they aren't equal, and we would have to return -1. So return -1. And both of these can lead to the end of the function. So this is the flow diagram to check that diagonals are equal. Okay, so let's implement this in code now. We'll start with creating a new project. So this is what you guys would have gone through in the test. There we go, and I'm going to call this ptest2. Okay. Okay, so I should have a source file here. Let's make sure that I can compile and run. Okay. Fantastic. Okay, cool. So we have a running program now, and let's start creating, or let's start writing this up. I'm going to include iostream here. Okay, so remember we wanted a couple of functions. The first one was some single row, and what we would do is we would send in an integer array, and it was going to be a certain size, a maximum size, and I'll get back to this in a second. We were going to send the size of the actual array, or the magic square, and we were also going to send the row number. Let's call it row. Now, what you guys must remember is that part of the requirement of the project was that we had a constant size of 10, or maximum size of 10. So I can actually create this array, and I can say that it's a 10 by 10. Now I can change 10 to whatever size I want. So later on, if I wanted to change this array size, I could make it 100 by 100 just by changing size. Okay, so we've got that. We've got a sum single row. Let's say sum rows. And in that case, we would send the array, and we would also send the size of the array. Then we also need int sum single column. All right, and again, we're going to send the array, and we're going to send the size and the column that we want to sum. And int sum cols is all of the columns and int sum mags, and again we're just going to send the array and the size. Okay, cool. So we've got all of the functions that we want to write, and now let's start with the flow diagram that we started with, which was the sum of the single row. Okay, so in the flow diagram we create sum equal to 0, and we now run a for loop for int j equals 0, j is less than n, j plus plus. Okay, and all we do is we go sum plus equals the array at row and j. Cool, and we return the sum. Okay, cool, so that's going to sum up a single row for us. Now, what we want to do is check to see that every single row sums up to the same number. So, as we discussed before, let me just see. I've got an error here. It's just a typo. Okay, so now we're going to sum up each row. So first, we're going to start with int sum equals be sum, or sorry, I called it count in the flow diagram. Count equals sum single row, and we're going to send in the array, we're going to send in the size, and we're going to send in row 0. So we want to see what the first row sums up to. Now what we do is we start a counter for int I equals 0, because we want to run through every single row. I is less than n, I plus plus. And what we're checking for is whether each row adds up to that count. So we're going to create that temp variable equals sum single row array n and I. So we're going to send in the row that we're counting. And sorry, like I made the same mistake in the flow diagram. We can start at 1 here because we've already looked at the first row. So we can start at the second row, I equals 1. And now we say if temp does not equal count, then we would return -1, because it would mean that the rows don't add up, right? If we get out of the for loop, it means that every single time we summed up a row, it was the same as the first one, which means we can return count, which is the sum of the rows. Now the columns is pretty much the exact same code. So for a single column, we're now going to run through every single row, right? So we're going to have for int I equals 0, I is less than n, I plus plus. And now what we want to do is we want to say sum plus equals the array at I and the column that we've locked it to. And at the end we return the sum. And now if you want to check all of the columns, again, we're going to create a count variable, which we're going to say we're going to sum a single column, and we're going to send in the array, the n value, and we're going to look at the first column. And then we're going to say, okay, we've looked at the first one, the first column, let's now look at all of the columns. So we're going to start at j equals 0, j is less than n. And in this case, what we want to do is we create a temp variable, and we now sum the single column from array n and j. And again, I do this every time. That should start at 1 because we've already looked at the 0th column. Right, if we are still in the for loop and we find that the temp value does not equal the count, means that it's not a magic square, and we return -1. If we get outside of the for loop, it means that all of the columns added up to the same value, and that value was count. Cool, so now we have that we can sum up the columns and the rows of our array. Now let's look at diagonals. So in the flow diagram, we created two variables, d1, and I must just set that to 0, and d2, also set that to 0. Now we created an integer k, and we started that at 0, and we need to check that k is less than n, right? And in this case, now what we want to do is, for the first one, it was a simple one. d1 is equal to array at k, and d2 must be equal to, so the row stays the same, but the column is now n minus 1 minus k. Cool. So what we do is we check, does d1 equal d2? If that's true, we can just return either one of them because they're the same number. Otherwise, if that's not true, so let's put an else statement here, we return -1. Okay, cool. So we've got all of the stuff that we did in the flow diagram. We've written up the code here. Now let's take a look at our int main. So basically, we had an input file. So we need to add fstream up here. Let's do that. Cool. And what we want to do is we want to do an ifstream input, and it was going to be an input.txt file. And the output, ostream output, must be output.txt. Okay, so we must remember that we're going to read in n, right? So the input file, the first value in the input file, to give you an idea of what that input file might look like, here's one from the test. We read in n, that's the size of the magic square, and then we read in each value in the magic square. So I'm creating n and I'm reading in n. Now I know that the number of values that I need to read in are n times n, right? Because if n is 4, the number of values that I need to read in are 16. 4 across and 4 down. Okay, So let's create our array, and remember that we've got a specific size. Now, we should initialize everything to 0, but if we're very careful with coding, we are only going to use the values within n, so it should be okay. So let's start up our for loop here. So for I equals 0, I is less than n, I plus plus. Okay, cool. So we've created, this is for the rows, and then int j equals 0, j is less than n, j plus plus. Okay, columns. What we're going to do is we're going to read from our input into our array at I, j. Okay? Now, it wasn't specified in the test, which means you can make the assumption that the input will be fine. So here, I would usually say, I'm assuming that the input file will have all of the values, and I don't need to perform error checking. Cool. If it was specified in the test, obviously you would need to check for errors if that was the case, or maybe the test would say you can assume that there are no errors, and then you wouldn't even need to write down this assumption. But now what we've done is we've read in n, the size of the cube, and we've read in every single input value. So now we can do the following checks. Let's check for, we can even make a function here. So let's actually create another function, and we'll call this bool is magic square. And what we're going to send in is an integer array and the size. Cool. Okay, so, and how would we check? Okay, so number one, we're going to go int rows equals some rows, and we need to send in the array and in. Then we're going to have int cols equals some cols, and we're going to send in the array and in. Cool. And finally, we're going to do int, let's call it diags equals some diags, and again we're going to send in the array and in. So all we need to do is we need to say if rows equals columns, right, and rows equals diags, then it means it's a magic square, right? Otherwise, if that's not true, and it's not a magic square. So now what we can do is we can do an if statement here. If is magic square, and I'm going to send in my array, and I'm going to send in my n value that I've read in. If that is a magic square, then output, let's actually not make it a boolean. Let's make this an integer. And what we'll do is, if it is a magic square, we'll return the rows or the columns or the diagonals, and if it's not, we'll return -1. So what that means is, if it is a magic square, it will return the count, and if not, it will return -1. Now, we don't even need to check. All we do is we go, our output file gets is magic square, and we're going to send in the array, and we're going to send it in. And that's it. Our output should now get -1 if it's not a magic square, and the count if it is. So let's create a new input file here. So we're going to do a new file. Okay, I'm going to call this input.txt. Cool. And I'm going to copy this example from the test and paste it in here. Right. And let's run and see what the output looks like in this case. Could crash. I haven't run it yet, so let's see. Okay, we've got an error. Okay, I don't have permission to open this file. Okay, so where it has been created, it doesn't like that file. Alright, let's create a new project then, and let's put it on my desktop. I'm going to to take all of this stuff over to this main CPP, and let's also take this input file, pop it in there, and let's close this one. So let's just delete it actually completely. Okay, so it says it ran successfully. Let's take a look on the desktop what we see. Output.txt 34, which is the right answer. Another nice quick test would be ones. So let's have a 5 by 5, and we know that 1, 1, 1, 1, 1, that would add up to a magic square because your diagonals, your columns, and your rows will all add up. So let's just make it a 5 by 5 here. And okay, so let's just paste that in here. Okay, let's see if that one, so that should add up to 5. Okay, again, let's just add up, yeah, 5. Okay, now let's do something where we know that it's incorrect. So let's just take this and make it a 2. So now the rows wouldn't add up, or the columns wouldn't add up, but the diagonals would be the same. That should fail. And let's take a look at our output, -1. So that's it. We now have a working magic square example.